In this question, two different graphs are obtained when a metal was reacted with an acid under different conditions. Graph 2 was obtained when the experiment was repeated with the same mass of metal but with excess of a slightly less concentrated solution of the acid. The question said, use your knowledge of how particles move in liquids to explain the shape of these graphs. Upon analyzing the question, there are actually two parts that we would have to address. Firstly, how particles move in liquids, which falls under the chapter of kinetic particle theory. And secondly, to explain the shape of these graphs, which falls under the chapter of speed of reaction. To answer the first part of the question, recall the movement of particles in a liquid. Particles in a liquid slide over one another. When the liquid particles slide over one another, there is contact between the particles. To answer the second part of the question, click on the video to recall the conditions required for effective collisions to take place, as well as the effect of concentration on the speed of reaction. From the video, we can see that in order for effective collisions to take place, particles must collide with the correct orientation and with sufficient energy. Also, the concentration of the solution affects the number of reactant particles available per unit volume. As such, to answer the first part of this question, we say that the particles in liquid slide over one another, hence are able to collide with sufficient energy and orientation. To answer the second part of the question, we say that when a less concentrated acid is used, there are lesser particles available per unit volume. Frequency of effective collisions decrease, hence the rate of reaction is slower. Let us now take a look at the comments from the examiner's report. The report states that this section was not well answered. Candidates often wrongly attributed the change in the shape of the curve to be the result of increases or decreases in the speed at which the particles move, which is an effect of temperature and not of concentration.